Microphone check. 1 2 1 2. What 1 2. Hit me with a bruh if y'all can hear me. Y'all know what it is. You are now tuned in to the network, the YouTube channel that takes complex networking topics, dumbs it down to a more simple language using all kinds of tools. Boson NetSim, GNS3, even G, and my favorite, my new favorite, Boson NetSim. Thanks to the folks at Boson, they gave me a promotional copy that I will be demoing. This ain't Groundhog Day, and nor this is a repeat of yesterday's lab. We're just going to be doing another MST lab, another STP lab. They've got tons of them. Y'all know how much I love this software now because, you know, repetition is the key to mastery, right? What the hell is going on with this thing, man? Damn resolution on my screen over here. If y'all want, y'all can cable up some devices just like this right here. 3 switches, 3 PCs, or hopefully you got Boson NetSim and you could just follow along like this, right? Or I could just explain the topics to y'all while I'm doing this, right? Give it some time for some people to tune in and stuff like that. Yesterday we did a lab on MST also. That was MST configuration. This one is going to be basically classic spanning tree as well as MST. So we're going to kind of go through just some of the STP basics and then convert this network into MST, I believe, if I'm not mistaken. It says here in this lab, you will learn how to create a virtual local area network, which we've done many times on this channel, right? To segment a network into separate broadcast domains, you will also review spanning tree protocol configuration on the switches on the network. So this is not a totally entirely new topic that, you know, on this channel. We went over MST pretty much all week. So next week we'll probably do some more. We'll stray away from the spanning tree. I know spanning tree making my head spin, but we got Dear Tech IT in the building. Appreciate you for tuning in. We got Kobe in the building. Appreciate both of y'all for tuning in, man. And there goes some bruhs right back to y'all. Y'all know I got to get my gallon in today. I've been trying. I literally walk around with a gallon of water. But today I did not have the whole thing filled up, so I'm just trying to play catch up here. I'm gonna go ahead and get started so we can maybe we can do some more labs than this, right? So this is the network we're gonna be playing with, right? 3 switches. This is basically this classic topology that they use to explain or demonstrate spanning tree. Usually, when you are any teacher or anybody that's explaining spanning tree concepts, they usually have this topology right here. The switches lined up in a triangle, just like this right here, to explain which one is the root, and then give you a root switch. Find out the root ports to take you to the root switch, and then show you which side is blocking. And that's probably what they're going to have us demonstrate here. Here's some basic commands that we already know, right? Configure terminal, enable, and exit, and then some of the other commands that we use to MST, which we've done all week pretty much, right? Revision, the name. We're going to run some spanning tree show commands. Then we're going to play with a little bit of BPDU guard and stuff like that. And the nice thing about Boson that I like is that before they just have you configuring shit, right? They ask you some basic questions to see if you know what the hell you're doing, right? So, like here, the lab tasks, right? They didn't ask us to configure anything yet. They didn't ask us to do anything, run any show commands yet. They just asked you some basic STP questions, right? So in this task, you will learn how the root bridge is selected. Which switch on the network is the root bridge, right? Well, we know by that, we need to at least run some show commands to verify that, right? And typically when you run that, when you do that, it'll tell you this bridge is the root. That'll let you know, right? So I'm going to be, right now I'm on switch A, right? Most likely that is the root bridge, but let's see. We go to user exec mode, then privileged exec mode, and we say show span, which is one of my favorite commands. Or we can just do show span summary, but I don't think summary gives you the root bridge. Does not give the root bridge. So what you got to do is, let me move this up. We need to fix our screen here. Organize our screen here. I know in the last stream, it looked a little bit smaller. I watch these, y'all know I watch my streams over and over again. So, and I noticed that the output was not very clear to me. So I made the font just a little bit bigger. Y'all let me know if y'all can see this font or not on the CLI here. So show span, we don't want to do show span summary because that doesn't give you the root bridge. You got to do show spanning tree, right? We do this and it shows us spanning tree information for each VLAN. We only have one VLAN configured on this switch, and it says, guess what? This bridge is the root. So that was easy enough. Switch A is a root bridge for VLAN 1, right? Which bridge priority is configured on the switches? So now they want us to check all three. God damn it. Yeah, excuse my cursing. Y'all know I don't give a fuck, man. I curse on my channel and stuff like that, man. Hopefully my boss is not watching or anybody else is, trying to hire me or something like that. I don't care. I'm just being me, right? Switch A, we say, well, let's check the bridge priority on that. Y'all know what the bridge priority is, right? The bridge priority is basically the number, this right here. Bridge priority is a number that tells us the lower the priority, the more likely it is to become a root switch, right? So right now they want us to know what the bridge priority is for each of the switches. So switch A, we know that since I'm the root, that is my bridge priority. 3, 2, 7, 6, 8. Now be confused with the bridge ID. Don't get that confused. The bridge ID is the priority plus the MAC address altogether. That is the bridge ID. So don't get those two confused. Bridge ID and bridge priority. So how was the root bridge select? Oh, we didn't do it. They wanted to do all three switches. So let's do that. B, what is the root, priority for that guy? Show span. Enable, show span. The bridge priority is 32768 as well, right? No, that is the root. This is me, 32768. So it is the same. Notice, this is information about the root bridge. Who was the root bridge? It was switch A. Now this is from switch B's vantage point, right? So this is the root bridge information, root switch information, and this is me, switch B's information. I used to get those two confused. Which one is which, right? This is the information about the root switch, and this is the information about the local switch, if that makes any sense, right? So local was at the bottom, root is at the top. I guess that's one way to remember it, right? So, and notice they are the same, so it looks like they were left by default, 32768, and most likely this guy's 32768 as well, right? Enable, show, span, and it is 32768 as well. So root switch priority, local switch priority, right there. RL, root, local. So they're all left by default on the same. How was the root bridge selected? Well, you would think, okay, since we said whoever has the lowest priority will be the root bridge, right? Well, goddamn it, they all tied. They are all tied. 32768. They all have the same priority. So the next thing is we have to have tiebreakers, right? So since they're all tied with the bridge priority, now let's go with the MAC address. Who has the lower MAC address? Whoever has the lower MAC address is now the root bridge. So let's see. Local switch, he is 000C. That's switch C. Switch B he also starts with a 000C. And switch A, he also starts with a 000C. Oh, we're pretty much the same here by the MAC address. Let's keep going further, right? Switch A is 1289. Switch B is 1461. Okay, so that means he's higher. So far he's elected the root bridge because he has a lower MAC address. And finally, switch C has 1380. And the root, this is the reason why he became lower the root switch, because not only they did tie with the bridge priority, but he has a lower MAC address, and that's why he became the root bridge. Y'all with me so far? You got any questions or anything like that? Like I said, this is just basic span tree stuff that we're going over. I know we said we're going to be doing CCNP topics, but guess what? When you look at the labs in Boson NetSim, and we go to view, where we at? View labs, right? And I just did MST, right? This pulled up all the MST labs, right? I already did this one and this one. We are on this one right now. And they're all encore exams. I mean, encore topics. So this is basically just a review of STP. So I know you're probably wondering, well, I thought we were doing CCNP stuff. Well, this is a review, so that's the reason why. So anyways, what was the next task here? Let's go back to topology. Close this. Yes. Another thing I like about Boson NetSim is, I remember how when I used to fire up my hardware and stuff like that, and we try to get this lab loaded up, I had to label and cable everything up, right? Then I had to get my trunks going, and then I had to make sure that the host names are going, blah, blah. I can jump straight into the topic that I want to learn and get right into it, right? So right now I'm doing spanning tree stuff, and I'm getting right into it. That's what I love about Boson NetSim. Sound like an advertisement for them, right? Well, goddamn it, that's what it is, right? Because they gave me a promo copy, and that's what I'm here to do. So switch B. So that was how the root bridge was selected, the lower MAC address, right? Question 4. Switch B, right here. Change the spanning tree priority of VLAN 1 to 4096. Okay, so that means they wanted to make a lower priority to make him the root bridge, right? Let's look at the show span output real quick before we do that, right? Show span, local switch is me right here. I am 32768. Here is information about the root. So R root, L local. That's how I'm going to remember it. I always used to get those two mixed up. I'm going to try to remember it this time. We'll change the priority. We go to global config mode, and we say spanning tree, what is it? VLAN 1 priority 4096. That's how we change it. So now that we've done it, we're lowering the priority to make him the root bridge. That's what they're essentially having us do here. Another thing you want to know about changing the priority or changing the switch to become a root. Remember last stream yesterday, we changed it by just using the root macro, right? We use the root keyword, and it's basically a macro, and it basically just figures out what everybody else's priority is and makes him lower by 4096, because you can only change the priority in multiples of 4096. And I ain't great at mental math, so that's why I like using the root macro. But now they're having us do it specifically with the priority of 4096, right? We press enter, and we do a show span real quick. We'll see now we have this port that's listening. Those two are forwarding right there, right? Do it again. He's still listening. And all of a sudden, we are now the root bridge for VLAN 1, remember? So now, switch A was the root bridge. Now we've become the root bridge. Switch B, right? This bridge is the root, and this bridge is the root. That's the local information, right? So local information, root bridge information. And notice there that they are the same information, right? MAC address is the same. Let me show you real quick. Come on, move, man. Where the hell is that arrow at? There it is, right there. Boom. You zoom out of this right here. That's what I like about this screen too. It's kind of like you can customize all this stuff. So MAC is the same. Root and local is the same, right? Because now I am the root bridge. Bitch, I am the club. Y'all with me so far? Let me know if y'all got any questions or anything. I'll do a refresh real quick. Make sure, because sometimes I got to reload to see what y'all doing. All right, y'all just quiet. All right, it's all good. All right, so that was question 4. Question 5, which switch is the root bridge for VLAN 1? Well, we've already determined that with that show output, right? Now I am the root bridge for VLAN 1. On switch B, issue the commands necessary to return the switch to its default spanning tree priority configuration. So basically, we got to negate the command that we just did by putting the keyword no, right? So do this, Control A, no, that removes it, and that should make switch A become the root again, right? Task 2, observe ports and determine their roles. In this task, you will determine the path that traffic takes between the network PCs. Okay, what is the state of all the ports on the root bridge? Let's go to root bridge. It was B. We should theoretically switch it back to switch A. Let's go to switch A and find that out. We do a show span, and it already tells us right there. Right now, they are learning, right? Because we kind of changed the topology. So now it's kind of figuring out which ones, and that's what classic spanning tree does. There's a little outage there, so it's starting to learn MAC addresses. Now they're all forwarding, and that's how you can tell that this bridge is a root. Not only because of that it tells us right there, but also all the ports are forwarding. That's how you know you're on the root switch. We here. Okay, appreciate it, man. Just making sure y'all just a little quiet over there. Tough crowd tonight, right? It's all good though. What is the state of the interfaces on non-root switches? So let's find that out. Let's go to switch B real quick. Show span. Don't worry, we gonna get away from we're gonna wrap up the spanning tree for this week. Next week we'll probably start doing some more Ether channel stuff. Let me pull up the this our study plan right here. I think I figured out a little I guess a little routine here. I started watching the videos for some more spanning tree stuff. Shout out to IP0. He had a good video on multiple spanning tree. You know, didn't really tell me anything new, but you know, I like to, like I said, gather information from other sources and see how they explain things as well. So we already did that lab, I think, last week. That lab last week. We did that lab yesterday. We're doing one of these today. That one right there. We're doing that one today. The GNS3 Volt lab, I don't know. I'll probably do that maybe tomorrow, or I'll probably do that on my own. I don't know. And then after that, I think we're going to move on to, yeah, lab 4 next week. We'll start doing some more Ether channel stuff, right? So port bundling and stuff, right? So if you want to copy this spreadsheet right here, make sure you join my Discord server. I'll give you an invite right now. Copy. Y'all run me with my likes. That is the Discord server. And then ask me in the chat, and I can give you a copy of this spreadsheet here, man. Like I said, I'm kind of jumping around here, but I think I figured out my swag right here, man. So, switch. What did they want us to know? What is the state of the interfaces on non-root switches? Okay, more specifically, the ports that make up the link between switch B and C. There's switch B, right? Let me zoom in for y'all. Bloop, 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 bloop. And there's switch C right there. They want us to know the information about this link right here, right? We go to switch B, and we're on switch B right now. Which is which? So we got 1, 3, and 4. So that means one of these is 1, 3, and 4. How can we determine that? I like to do show CDP neighbor. I like that command. That usually tells me we know that there should be 2 CDP neighbors. One of which is switch C, right? So that link right there is connected to switch C. So let's do show CDP neighbors. I like that one. Unless there's another way, y'all know. So yeah, switch C is connected to F803. So that tells us that this is F803. Y'all with me so far? Right? So that's F803. And then they want to know what is the state of that interface. So let's look at F803. What they have right here. F803 is blocking. And it's a designated port. The role is designated and it's blocking. Why is that? Well, it has a higher cost, for one. If we open that up, it could cause a loop in the network. That's how spanning tree works, right? Shout out to Radia Perlman. She the lady invented this shit, right? She's like a fucking mathematician and shit. I think she's still around too. But yeah, really deep subject, man. It can be real. It's a really deep subject. But anyways, they figured out a way, you know, with the way spanning tree works, to stop loops from happening at layer 2, and that's what it was designed to do. There's just different flavors of it: PBST, STP, or this is classic spanning tree, and then what we've been covering over the week, multiple spanning tree. So, like I said, spanning Raya Perlman, she basically came up with the original, you know, inception of spanning tree, and then these different companies came out with their own, and then the IEEE created the open standard, which is multiple spanning tree, or MST. So what is the role of a port that is displayed as DSG? That's basically designated. It's a designated port, right? We can only have one designated port on each segment. What's the segment? This is a segment right here. So this guy is designated, and it is blocking. So most likely this guy, let's see. Let's go to switch C, what it is. Switch C, his it is also designated, but it's forwarding, right? Let's verify that with the show CDP neighbors. I like that command, right? Show CDP neighbor. Where's switch B connected to? F803, and F803 is forwarding. So right here it's blocking, but it's forwarding on this link right here, and they're both designated, right? Y'all with me so far? Right, switch B, right? Yes, yes. Local interface F803. Device ID, the neighbor is switch B. So what are the spanning tree roles of the ports on the root bridge? Well, we determined that already, right? We'll go to root bridge, right? The root bridge was this guy right here. And notice those words are kind of like, or terminologies, they're kind of interchangeable, or, you know, synonymous with each other. They say root bridge because back in the days they didn't have switches. They had what's called bridges. That's how you bridge your networks together, with a bridge. But then they just kept that term. You can call it a root switch. I like to say root switch because I get confused with bridge. So this is the root switch right here, right? I mean, we used to give him the crown, right? So he's the root switch. And they wanted us to know, what are the spanning tree roles of the ports on the root bridge? Well, we already see it right there. Designated, designated, designated. That's the roles. And they're all forwarding, right? Does a port in the BLK state forward network traffic? Tell you right now, that doesn't mean Brooklyn or block, right? BLK means block. So it's blocking traffic from forwarding, from being forwarded on that link. So no, it does not forward traffic. Trick question there, right? Well, not really, if you kind of look at it, right? Question 5 says, describe, and notice we haven't done any real configuring yet. They just ask you, that's what I like about Boson. They trying to quiz you on the theory first before they start having you, because you don't want to just be configuring shit all day long and you don't know what the hell you're doing. You want to know the theory behind some of this stuff, right? And that's what I like about Boson, because you're supposed to obviously read some of this stuff, you know, from the official cert guide or some other theory book. Then you come over here and try to practice this stuff. But before they have you just, you know, typing away, they quiz you on the theory first, right? So describe the path a packet would take through the switches between PC2 and 3. What's PC2? Here's PC3. They want to know how we would get from, if we sent a packet from here to there, how would it take? You would think, okay, by looking at it, well, it should just go straight over here. But we already determined that this link right here is blocked, right? So that means, since we know that this port right here is blocked, that means to get to PC3, he's going to go from here to here to here to there. That's how he gets to PT3. That is how the path would take, right? With me so far? And if we're not even sure, there's a solution guide at the bottom, and let us know if we're right or wrong, right? Or if NetworkBruh is steering you wrong. In this step, you will observe the changes of port states as spanning tree LX a new root bridge, which we've already determined. Remember when I did the show span and it went to listening state and then learning state and all of that, right? So you will be issuing the show spanning tree command multiple times. I already did that, right? On switch A immediately after you change the spanning tree priority on switch B. So issue the show spanning tree command on switch A. So we go to switch A. We already did that. See, I already did that. Show span. But we'll do it over again anyway, right? So span, right? It's show spanning tree, right? I just say show span for short, and I just tabbed over, and you see that, right? Issue the show spanning tree command on switch A and review the initial output. On switch B, change the spanning tree priority of VLAN 1 to 4096. I think we already did that earlier, but we're going to do it again. And then immediately access the console of switch A and issue the show spanning tree command. So what they want us to do here is, on switch B, they want us to, so right now, switch A is the root, right? They want us to change this guy's priority to make it lower, to make him become the root, and watch what happens on this switch when we elect him to be the root bridge, right? That's what they want us to do. But they want us to go over there quickly to see what happens, right? So let's look at the state of this guy's show span output. Show span, right? We see we have that blocking port that we determined, right? This guy right here is blocking. Can y'all see my CLI? Is it legible? Because like I said, I watched the stream earlier, yesterday's stream earlier. I was like, damn, I can't even see this shit, man. How these people, nobody ain't complaining. But let me know if y'all can see that or not. But anyways, that port's blocking. We said we got a root port, so the root port takes us to the root bridge, and then FA04, that is forwarding because we have a PC there, right? So we're forwarding traffic on this link there, right? So blocking, root, forwarding. We'll change the priority. Spanning tree VLAN 1, priority 4096. Press enter, and we go to switch A. See what happens, right? See, they were all forwarding last time. We do show span again, and we see now we're listening, and only this one's forwarding, FA04, which I believe is that PC right there. That's still forwarding, but these two are in a learning state. I mean, a listening state. Show it again. Now we're learning. So now we're learning MAC addresses. We're learning who is which one is going to be our designated port. What is the cost for this? What's the best way to root bridge? So it's still learning. We run it again. We're still, now that one's forwarding. FA02 is still learning. Run it again. Now they're all forwarding. So now they're all forwarding. They're all forwarding. And we have a root bridge now. Now we have a root bridge. A root switch does not have a root bridge because it is the root, right? But now this switch is no longer the root, so now he has a switch he has a port that'll take us to the root bridge, which is this guy right here. Now this guy is the root bridge, right? So we go to switch B. We'll verify that with what? Show span, and we see this bridge is the root, right? Because we changed the priority from 32768, right? Local at the bottom. Where is he at? From 32768, and we changed it to 4096, and now local, this bridge is the root, 4096, and that's how you became the root. And remember, root switches don't have a root port. because he is the root, and then all ports are forwarding. Y'all with me so far? All right, so, and that's what we did. Press up to quickly access the commands and see that they're all in forwarding state. What did you observe at the spanning tree on the switches converged? We saw that it went through the listening, learning, and then forwarding state. That's what we saw. Switch B returned to switch to its default priority configuration. So go to switch B. Basically, they want us to negate that command. So they got us fixing shit and putting it right back the way it was. So, the hell, whatever. Global config mode, control A, no, remove that. Now he's back to being, now switch A will most likely become the root again, right? On switch B, on switch B's FA01 interface. So we're going to switch B, interface FA0/1. Issue the spanning tree cost 100 command to influence the path traffic from switch B to the root bridge. So FA01 was, which port was that? I think it was this port. They want us to change the cost to 100. Well, what's the cost now? Let's see. Let's see. Show span. FA01, the cost is 19, and it is our root port. So this is the port that's going to take us to root bridge. They want us to change that from 19 to 100, right? This will influence which ports are going to be blocking now, et cetera, et cetera, et cetera. So most likely it'll not become the root bridge anymore because, or yeah, the root, like the root port to take us to the root switch, then because we're making the cost higher. The higher the cost, the less likely it is to become the root switch. The lower the lower the cost, the more likely it is to be a root port, right? So we go to that interface. They want us to change that. Configure terminal interface FA interface FAST 0/1 spanning tree cost. Oops, spanning tree. So I can spell cost 100, right? And then what did they want us to see? What is the spanning tree state of switch B's FA01 interface? Well, last time it was forwarding with a cost of 19, and it was a root port. Now, if we do a show span, it is learning now. It is a designated port. Now we have a new root port, and then the cost is 100. We're still learning. Run it again. Still learning. Still learning. Still learning. And that's the thing about spanning tree. We got to go through all those states. Pop quiz. How long does it take before it gets into a forwarding state? Do y'all know how long a switch will take? If it's running STP, spanning tree protocol, this is what we're running right now. We are running, actually we're running PBST. How long will it take before it goes into a forwarding state? If you had a timer, you'll find out, right? Now it is blocking, right? Because we changed it to a cost of 100. That's our pop quiz for today, right? So configure port fast, task 3. Configure port fast and BPDU guard. In this task, you will observe changes caused by port fast and BPDU. By default, when a switch is powered up or when a new device is connected to a port on the switch, what spanning tree states do the ports transition to? Well, we saw that, right? We saw that it goes from listening, learning, then forwarding, right? What can you do to cause a port on a switch to immediately transition to the forwarding state? Well, that's port fast, right? Aptly named, right? It goes into a forwarding state fast. It skips the listening and learning and goes straight into forwarding. We want to do this only on access switch, access ports. So that's one thing you want to learn about port fast. When BPDU guard is enabled on a port, what occurs to an interface when a BPDU packet is received? Read that back. When BPDU guard is enabled on a port, what occurs to an interface? What occurs to an interface when a BPDU packet is received? Well, we know that BPDUs are kind of like keep alive messages, let you know, like, hey, you know, I am a switch, and this port is participating in spanning tree, and I could be either forwarding traffic or whatever, right? Most likely forwarding traffic. Now, if we have a port where BPDU guard is enabled, there's some ports we don't want BPDUs to be heard on, right? So most likely like an access port. So like this port right here, we can have BPDU guard on it. If we plug in a switch there, because we did not expect one, then that switch will start sending BPDUs, and BPDU guard will effectively shut the port down. That's what BPDU, and I deal with this shit a lot all the time at work, because there's, I ain't gonna say no names or whatever, but we have some people that like plug into it, you know, an access port and be like, hey, this network port is not working, blah, blah, blah. You go in there and realize BPDU guard is enabled. It does work. It's just, it's designed to do that, shut down when we are expecting, or when we are not expecting BPDUs to be, you know, heard on that port. So that's what BPDU guard does. It shuts the port down. It puts it in. It doesn't really shut it down. It puts it in the disabled state. That's a more accurate term. Pete said 50 seconds on default STP. That's correct. 50 seconds. And Juan got it correct too. It can disable the port or block the packet and log it. That is correct as well. That is correct as well. So it depends on how you have it set up. No, that's actually port security, Pete. I think that's port security. It really disables the port. And as a matter of fact, we might be able to demonstrate that now. What is the purpose of BPDU guard? Well, I think I just explained that. What is the purpose of BPDU guard, and when is it typically used? Like I said, it is typically used on access ports, ports that you don't expect BPDUs on, right? You don't expect a PC or somebody's laptop that you plugged into this port to send BPDUs because it's an access device. It's an end device. If you plug up another switch or somebody has Kali Linux or some kind of any kind of hacker tool to send BPDUs and stuff like that to influence the root bridge and fuck up our network, then BPDU guard will shut that port down, and it's doing what it's designed to do. That is what BPDU guard, that's the purpose of it. What command can you use to determine the operational mode and administrative mode on a port on a switch? Well, y'all know we could do show run, but y'all know I try to get you guys to stay away from using show run. What we want to do is do a show interface and then the switch port keyword at the end to see the operational mode and the administrative mode. So we do show, let's say, well, they didn't tell us to do one yet. Let's pick one, FA01. Interface FA01, add the switch port keyword at the end, and it tells us effectively the administrative mode. So 01 is trunking, and the operational mode is trunking. So 01, I think, is that port right there, and that port is trunking. That's one thing I don't like about Boson. Yes, I do have, and I said this is the demo of their product, but I do have constructive criticism. And it might be because it'll be too much text on here, but these ports are not labeled. Packet Tracer will give you those labels of those ports, right? So I'm trying to guess which one is which. I got to do show CDP neighbors and shit like that. Even if we zoom in, you still ain't gonna see what the ports are, right? Can you do that? Let's see. No, I don't think you see. You can't see. You can see the links like that. Let's see. Yeah, that's what you could do. But and highlight them like that, but that's about it. You can sort them, but you can't really see. Let me see. That's all you can do is highlight it. What kind of feature is that? But oh well, whatever. It is what it is. So that is the command that we can use. The add the switch port keyword at the end that tells us the administrative mode of the port as well as the operational mode of the port. What is the default administrative mode on a 2950 switch? Default administrative mode on a 2950 switch. I don't know what kind of question they mean by that, but I believe it's a static access. Since we don't know the answer to that, since I don't know the answer to that, we'll check the lab solution towards the end. And don't let me forget, y'all. And run me with my likes, man. Run me with my likes, man. Please run me with my likes, man. And subscribe if you're not subscribed to this channel. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Again, this is just a demo of Boson NetSense products. And let's move on with the show. Switch B. On Switch B's FA01 interface, so this guy right here, enable BPDU guard and observe what occurs when a bridge protocol data unit, or BPDU, is detected by BPDU guard. So I think this is FA01 right here, right? No, that is FA01. Yeah, I think that's FA01. Let's see. Let's do show CP neighbor real quick. Yes, so switch A is connected to 01. So this port right here is FA01. They want us to enable BPDU guard on that port. Go to global config mode, interface FA0/1. We say switch port. I'm sorry. Yeah, switch port. No, my bad. It's spanning tree. BPDU guard enabled. That turns on BPDU guard, right? We press enter. Do we detect BPDU? Immediately, right? And it's a level 2 message, right? Y'all know what level 2 is? Like, it's almost catastrophic, right? Remember, it's a level, a range between 0 through 7. 0 meaning it's like call the fire department, call the police, and level 7 is just debugging purposes, and level 6 is informational, and so on and so forth. This is a level 2 message. It blocked the port. We received the BPDU on port FA01 with BPDU guard enabled. We're disabling the port. So that's what happened right there. We can verify that with what? Show interfaces status, and we'll see the port is disabled. right? It is a trunk port. So what does they want to see here? Issue the appropriate show command to display the status of the interfaces, which is what we just did, show interface status. What else they wanted to do? On switch B's FA01 interface, explicitly disable BPDU guard. So we enabled it. Now they want us to disable it. Okay. We go to global config mode, interface FA01. We just negate that command basically with the no keyword, right? That turns off BPDU. But notice, do show interface status. It is still disabled, even though we removed that feature. To re-enable the port, y'all know what you got to do to turn it back on? Pete S said, how you finding NetSim? Oh, yep, you're probably right. Pete, the good folks at Boson gifted me with this promotional copy of Boson. Pretty much their entire line of products. They gave me the Encore version of this application. They gave me the NRC version of this application. I'll show y'all real quick. Get rid of that. Bloop. They gave me the CCNA version of this, the NRC CCNA. They got some demo labs in here, which probably just like demo labs. And they also gave me copies of the entire line, man. And like I said, I was speaking with the marketing manager. They gave me this copy, and they said, yeah, that's fine. Go ahead and demo it and let them know how our products is the shit, man. Let them know, man. And once I reach 5,000 subscribers, I am going to be giving away a copy of an application of your choice. So whether it's the CCNA version, the Encore version, the NRC version, you're just going to have to let me know once I run a raffle. I'm just trying to reach 5,000 subscribers at least by the end of the summertime. So if you're not subscribed to the channel, man, make sure you're subscribed, man. You know, hit me with that like button, and most likely, yeah, like I said, I'm going to be giving away a copy of this stuff, man. So yeah, Pete, I haven't seen you in a while, man. That's what I've been doing, man. Just been playing with Boson NetSim. Like I said, I've been loving their products. I used to use it back in the day when I used to study for CCNA and stuff, and I thought it was pretty cool. But it's pretty cool for them to, you know, I wasn't doing YouTube stuff back in the day, so it's pretty cool that they gave me this. So anyway, notice that the port is still, what we said about that. The port was still disabled, even though I turned off BPDU guard. Why is that? Y'all know why? Y'all know why? Y'all let me know. So, did switch B's FA01 interface come up when you disabled BPDU guard? No, it did not. Enable switch B's FA01 interface. Anybody know how to turn it back on? Even though it's disabled and we turned off BPDU guard? Cue the Jeopardy theme song here. You, sir, in the back. How do I turn this port back on? That's right, Pete. Shut, no shut. I was waiting for somebody. I wasn't going to move until somebody said it, man. Shut, no shut. We got to shut, no shut the port. So we shut down the port. And notice it is changed administratively down. We no shut it. And now we do a show interface status. It already tells us right there with that syslog message that it's up. And now it's back up. So even though we turned off BPDU guard, the port was still in the disabled state because it found some BPDUs on it. And we was not expecting any BPDUs on there. It was a trunk port. So what else we want to know here? On switch B, administratively shut down interfaces FA01 through 4. Now, this is the weird thing I don't like about. I don't know if this works or not, but notice it says shut down interfaces FA01 through 4. So I should theoretically use what? The interface range command, right? So interface range FAST01 through 4, right? That doesn't work apparently. I don't know why. There must be something wrong with this interface, with this command right here. Y'all let me know if I did something wrong here. But I think you can only that's weird. That's weird. Let me check again. Interface range fast Ethernet 0/1 through 4. That don't work for some reason. So I think I'm gonna have to do this one by one, right? So we have to shut down all those interfaces one by one. FAST 0/1, shut 0/2. Oops, I said 22. 2, shut 3, shut 4, shut. Right, we shut down all those ports as they said. Preceding commands with do enables you to, yes, we already know that already, right? If y'all don't know that, right? So, you know, some commands work in user exec mode, some commands work on privileged exec mode, and only some commands work on, and all the commands work on, most of them, on global config mode, right? Well, if there's some commands that you need to run in global config mode that you can't do, and vice versa, just run the do command, right? That's what they basically telling us here, right? So let's here issue the do show spanning tree, right? So do show span, right? That's just in case y'all don't know, right? So do show span ning. What the hell happened to it? Interface VLAN 1 is down because we shut down a specific port, so that's probably why. But it says here on switch B, enable those commands and then do the do show span, right? So now they want us to re-enable it. I don't know why the hell they told us to shut it down. Oh, because they want us to observe the spanning tree states. That's what they wanted us to do. And I just shut them down and I didn't even check. Well, right now we don't have any instances of spanning tree because we shut down interface VLAN 1. That's the reason why that happened. So let's just go ahead and re-enable them one by one. Don't know why it's like that. Is it the spacing 01-4? I don't know. Let's see. I'm gonna try that. Let's see. Let's try that. Interface. Get out of this. Interface range FAST 01-4. There you go, man. Man, listen. I appreciate that, Pete. Now, on real hardware or real application, real Cisco iOS, you don't have to put that space. But I'm glad you pointed that out. I didn't think, man. This is why I fuck with y'all, man. See, it was a spacing there. I don't think that on iOS you need to put that space there. So that's why I was just so glued to working with my hardware and stuff like that. But anyways, now we can just do no shut one time and bring them all up just like that. Shout out to Pete for that one. And let's see here. They want us to do show span and view the output quickly. Do show span so we can see. See, now that port is listening. That port is listening. Run it again. Listening. So they just want us to observe the spanning tree states like we did earlier, right? Until it gets to forwarding, right? Now it's learning, right? So listening and then learning and then forwarding. 30 seconds, just like who said it earlier? Yeah, Pete said it. 50 seconds rather. 50 seconds, and then I think it's 30 for rapid PVST, right? Y'all correct me if I'm wrong, because we're running rapid PVST. No, this is PVST. That's right. Okay, so y'all with me so far? Let me know if y'all got any questions or anything. With port fast enabled, we're almost done here, right? We only got one more task before we get to the MST stuff, right? We're just doing some classic spanning tree, and then we'll wrap it up. Wrap it up. Wrap it up then. On switch B, FA04 interface. So we'll go to switch B, go to FA04, interface FA0/4. Enable port fast and BPDU guard. So it's spanning tree, port fast, and spanning tree, which by the way, that is a Cisco proprietary technology. BPDU guard enable. That turns on BPDU guard for that port, right? That's FA04, which is this right here. That interface right there. Y'all let me know if y'all can see the CLI or not. That interface right there, right? So does it tell us on this right here, on this link? No, it doesn't. It doesn't. Okay. So remember, this stuff is just an emulator, so the commands are just what the devs programmed into it. Exactamundo, Pete. This application is actually not an emulator. It is a simulator, if you want to be technically, if you want to be technical about it. It's a simulator, so it simulates the environment of Cisco iOS. So they developed the way that interface range command doesn't work exactly the way it does on iOS. You had to put a space on it. You don't have to do that on Cisco iOS. So remember, this is a fake application basically. So, but it does what it needs to do, we needed to do to learn this stuff, right? So now on switch B, they want us to administratively shut down FA0 1 through 4 interfaces. So do the same thing again. right? Interface range, FA0/1 through 4. Shut those guys down. We did this part already, right? They did that. Didn't they tell us to do that already? What the hell? And then they wanted to show the spanning tree states again. Interface went down. Do show span. Sappin. And that's pretty much it, man. We lost the spanning tree configuration because, not spanning tree configuration, but instance, because we shut down VLAN 1. So that's basically what happened there. Let's do a no shut, bring it back up, and turn it back to normal, right? And let's move on to the next task. Task 4, compare PVST and MST, right? Two different types of spanning tree flavors, right? Rapid or PVST, which is per VLAN spanning tree, is Cisco proprietary spanning tree technology. So Radia Perlman birthed it, right? She the inventor, right? She the GOAT. She the one that created it. And then Cisco was like, hey, we like this shit, man. They created their own proprietary rapid spanning tree protocol, right? Rapid PVST and all of that. And then the IEEE, which is the like the, how do I say, the standards organization that created their own spanning tree protocol, so we can use it on all type of devices, not just Cisco devices. We can use it on, you know, HP switches or 3Com, whatever the fuck, right? In this task, we will create 2 VLANs and use various commands to determine the root bridge of multiple VLANs, right? So now we only had one spanning tree instance on these switches. It was for VLAN 1, right? With PVST, we can have a spanning tree instance for every VLAN, right? Which we've discussed in the past couple streams, right? So which switch is configured as the VTP server? We know that command, right? We do show VTP status to verify that, right? Look at that. We can move our stuff, but we don't want to do that, right? So let's see. Let's go to switch B and roll the dice, right? Let's do a show VTP status, and we'll see he is a client. So that is not the server. Let's go to switch C, roll the dice and set and check to see if he is the server. Show VTP status. He is also a client, so most likely this guy is a server, right? So client, most likely he is a server. So not only is the root, but he is a server. He has a lot of roles there, man. Show VTP status, and he is a server. Which we got Treg Henry in the building. Just made it back. Appreciate you for tuning in. On switch A, create VLAN 10 and 20. So let's go to switch A. We are in switch A. Go to global config mode. We said VLAN 10, 20. No, that's not how you do it. I think you got to do space 20, right? Space 20? Nope. How do you create 2 VLANs? I think you just do space. No, VLAN 10. We don't want to do through 20. 20. Then you can't do that. I thought you could do that. Yeah, I remember this is just an application that no, you can't do that. You can't do that. You don't want to do 10 through 20. How you do this? I don't want to do it like one at a time. I thought you could just do both at the same time. 10, 20 like that. Do show VLAN. And that created nothing just yet. You got to get out of it to really see it. Do show VLAN, and now you see we created a VLAN 10, but it didn't do VLAN 20. So we got to do it one at a time. Whatever. VLAN 20. You know the trick for that one too? Now we created VLAN 20. All right, good to go. What else they wanted us to do here? So on switch B and C, verify that the VLANs were added to the VTP clients. So this was the server, this was the clients, right? So basically, instead of having to create VLAN 10 and 20 on here and VLAN 20 and 20 on here, we just created it on here and it propagated through the trunks and created those VLANs as well. Theoretically, it should have done that. So let's go to switch B and verify that, right? Show VLAN, because remember before it only had 5 VLANs. We do a show VTP status and we'll see now we've got 7 VLANs. See, so it did work, right? We verify that with show VLAN brief. We'll see VLAN 10 and 20 were created. So most likely it was created on there as well. I'm gonna go check that as well. Also, so switch A. What lab are you working on? Good question, Treg. I'm working on the STP and MST lab in Boson NetSim version 13. If you're not familiar with Boson, they're a company that, you know, they've got applications that allows you. It's a simulator that allows you to, you know, play with routers and switches and lions and tigers and bears, oh my, and not have to download iOS or anything like that. It's a simulator, so and it asks us basic questions about the theory and stuff like that, and we can configure it just like having hardware and stuff like that. I'm just demoing their products. They gifted me with a, you know, a promotional copy and said that I could tell people how their application is the shit, man. So, and that's what we're doing here. We're just covering spanning tree, the different flavors of spanning tree, PVST and MST, and seeing how they work and stuff like that. Right now we're creating VLANs. We're on the portion that we're creating VLANs, watching them propagate across the network, and then we're going to create spanning tree instances for those. So good question, man. Switch, we verified on we verified on switch B. We didn't verify on switch C. But if y'all want me to do it, I'll do it for the sake of completion. Damn it, just in case there's some jackass in there, man. You ain't checked switch C. VTP status. There, 7 VLANs, right? So we get to go. On switch A, go to switch A. Bloop. Verify that the switch is the root bridge for all VLANs, right? We'll do our favorite command, show span. And we'll see we are the root bridge for VLAN 1. Bloop, right there. We are the root bridge for VLAN 10. This bridge is the root, right? VLAN 10. And also, this bridge is the root for VLAN 20, right there. Right there. VLAN 20. So yes, we are the root bridge for all 3 VLANs. On switch B, go to switch B, bloop, that guy right there. Configure a priority of 4096 for VLAN 10, right? So what is the priority of it right now? Let's see. Show span VLAN 10. Right now the priority for VLAN 10 is the default 32778. Y'all know how I came up with that number, right? It was the default is 32768, but then it added the VLAN ID, which they don't show you on here. On Cisco iOS, it'll show you what the VLAN ID is, but it essentially is 32768 plus the VLAN ID. The VLAN ID is 10, so it's 32768. And I know I'm not the greatest, you know, mathematician ever, but 32768 plus 10 is 32778. That's how they came up with this number right here, right? So now they want us to configure the priority of 4096 to essentially effectively make it the root bridge for VLAN 10. That's what we're having us do here. So go to global config mode. Spanning tree VLAN 10 priority 4096. If I can type, press enter, and now we do a show span VLAN 10, and we'll see we are now the root bridge. Now we are now the root bridge for VLAN 10. Now they want us to do the same thing for switch C, but VLAN 20, right? Go to VLAN switch C, go to global config mode, spanning tree VLAN 20. 520, 20, priority 4096, right? And we'll check, verify our work, show span, VLAN 20, and now I am the root bridge for VLAN 20, right there, right? And right now, since we changed up the topology and stuff like that, now we're in a listening state. We run it again. We're still listening. We're still listening, right? Now we're learning, and it goes through that until we get to start forwarding. So, and that essentially will turn us into the root bridge and stuff like that after that, right? So how many questions we got left? We only, let's see. We got like 4 more questions there. And on task 5, we got like 7 questions, and then we're wrapping it up, right? Task 5 is the last task, right? So on all 3 switches, verify that switch A is the root bridge for VLAN 1. So let's go to switch A. He should be this root bridge for VLAN 1. Show span VLAN 1. And we'll see here's a root bridge. Another command we could do is what? Show span root, I believe, right? Yes. No. Root. Cost. Detail. Port. Priority. We could just do priority. There it is. No. No, that's not what we're going to do. What's another one? I think detail. That'll give way too much information. I don't want that. I don't want that. There was one that just gives you, I think it's just root. What is it? Root what? Detail, port, priority, the MAC address of the root bridge. I like that one. Address. No, that's not it. That gives you the MAC. Detail, root port. There was one that just, I can't even remember what it is. Maybe it's a priority. I already did priority. Whatever. I think that's good enough. So we know that, let's see, switch B and C, display the priority settings. Switch B. Okay, so on all three switches, verify switch A is the root bridge for VLAN 1, which we did. Right, so VLAN 1, where is he? I'm on switch A right now, right? Let's just do it again. Show span VLAN 1, right? I am the root bridge for VLAN 1. So yes. You want me to do it on all three switches? Y'all want me to do it on all three switches? Yes, Kelvin. More spanning tree. Show span VLAN 1. And we'll see he is not. Interesting. They said to do that on all three switches. Right? Let's see. On all three switches, verify switch A is the root bridge for VLAN 1. Switch B says somebody else is the root bridge for VLAN 1. That's interesting. Let's see. Switch C. Who is root bridge for VLAN 1? Oh, it's not going to say this bridge is the root. That's why. So it just tells you who is the root bridge. So span, I was just looking at it wrong. I just always stay focused on looking for this bridge is the root. So span VLAN 1, and this is information on the root bridge right there. That actually is the MAC address for switch A. 3959, right? On switch B and C, display the priority settings of VLANs 10 and 20. This priority settings. We could just do, let's go to switch B and do show span. We did priority right there. Root priority is what we could do. The priority settings of VLAN 10 and 20 right there, 4106 and 4116. That is the priority settings right there. We could also do show, y'all know I don't like to do show run, but we can do show run and you'll see the priority settings right there. See, 4096. We did that manually anyway, so we already knew that. So question 9, which switch is the root bridge for VLAN 1? We already determined it was switch A. And what is the spanning tree priority of VLAN 1 on the switch? Let's go back to it and see. The priority is 32768, and this bridge is the root. Why is he still the root, right? Because we had a lower MAC address. Remember from earlier in the stream? Because of that half of the OUI with MAC address. Y'all remember that? He said the commands just show spanning tree root, but evidently NetSim doesn't have it. Yes, that's what I thought it was. Exactly. Show span root. That's exactly what I was looking for. And that's what I said, man. And the application is aptly named. NetSim is a simulator. It just simulates the environment of iOS. So it's not going to give you exactly what you're going to see on like Cisco iOS or iOS XE and stuff like that. But it gives you at least enough to pass exams and shit like that, and at least have a good feel for these show commands and how things are configured and stuff like that. So again, this is a simulator. So I do love this application, but at the end of the day, the shit is fake. All right, so we did that. We saw what is the spanning tree priority of VLAN 1. We did that already. The priority was 32768. What is one of the differences between the show span command and show spanning tree summary? Well, one gives you a summarization of the spanning tree topology, and the other one gives you detailed information for each VLAN, right? So we did show span by itself, right? So here's the difference. Show span, and it gives you information about VLAN 1, the root switch information, local switch information. What else? Port cost information, priority, all of that shit, right? VLAN 10, same thing for each VLAN, too, per VLAN. It shows us that. We do show span summary. It gives us a summarization of the spanning tree topology. What ports are blocking, which ones are listening, learning, forwarding, the default spanning tree features like port fast and uplink fast and loop guard, all of that stuff, which one's on by default and which one is turned off, all of that. That's the basic difference between the two. So, but show span gives you more detailed information though. So task 5, final task, implement MST, right? What we came to do. You can minimize the number of spanning tree instances of spanning tree running on a switch by implementing MST. In this task, you will combine VLANs into a single MST instance. What I've been saying all week, or all last week and this week, right? We said we can have 500 VLANs on a switch running PVST, right? However, that means we'll have 500 instances of 500 instances of spanning tree running on our switch, which could cause a lot of overhead on our CPU, and it could just be a lot of work, a lot of administrative labor if we need to fine tune our spanning tree topology. Well, MS-Tree can kind of make it a little easier for us and the CPU by grouping all of these VLANs into one instance, or sometimes we call it a region. And like, let's say we have 500 VLANs, we can put VLANs 1 through 250 in one instance of STP, and VLANs 251 through 500 in another instance. So even though we have 500 VLANs, we've got 2 instances of STP, right? That's the beauty of MST. And that's what they're gonna have us do here. On all 3 switches, change the spanning tree mode on the switches from PBST to MST, right? We did that last week, and we're gonna do it again today, right? Remember, repetition is the key to all mastery, right? So we go to switch 1, or switch A rather, go to global config mode, and it's just spanning tree mode. And let's see what we're running first, right? I like to do show span sum, and we'll see we are running in PBST mode. Is that an alarm? Holy shit. Hold on. I'm gonna check that in a second. Spanning tree mode, we're in PBST mode right now, right? We do we go to global config mode, we say spanning tree mode MST. That puts it in MST mode. We can verify that with show span sum. What the hell is going on here, man? I'm gonna holler at you later, man. So span sum, right? And then let's see here. We are in MST mode now, right? So what else we want to see here? Combine VLANs 1, 10, and 20 into a single MST instance. So remember, that's why they even call it. It was aptly named per VLAN spanning tree, which means we have an instance per VLAN. So that means we have an instance of spanning tree for VLAN 1, 10, and 20. They want us to combine it into a single instance. Use 1 as the instance number, 1 and revision number, and use group 1 as the name for the instance. So let's go global config mode, and we say, what is it? Spanning tree, MST configuration. That puts us in MST configuration mode. Oh, I didn't put these guys in MST mode yet, right? The rest of these guys. Let's do the same thing on the other guys. Let's put them in MST. Let's put them in MST. He said, where is the discount code? On the home page. Summer 21. More spanning tree. Yeah, the command. Okay, so I'm just catching up. All right, appreciate that, y'all. So go to global config mode. We say spanning tree mode MST. Oops, mode MST. Do the same thing on switch C. Global config mode. Spanning tree mode MST. What else we want to do here? Y'all give me a second here. All right, so spanning tree mode MST. Of course I am, man. What the hell? Spanning tree mode MST, and then we said we wanted to put them into one instance. So let's go to switch A and do that. We put those guys in MST mode. Good. So that puts us in MST configuration mode. What we want to do here? Use 1 as the instance number. So we do spanning tree. I'm sorry. Instance 1 is VLANs 1, 10, and 20. So we got to do 1 and then comma 10, comma 20. That puts them into one instance. They also wanted us to name it group 1. So name, this is also known as is colloquially known as the region. So you would think they would have just put the word region there so we can go, because remember, MST instances are created in the regions, but we just put the keyword name to actually put it in a region. They want us to name it group 1, and then revision, that can be any number, but they wanted us to use 1 here, and they want us to do the same thing on all 3 switches, I believe, right? Yes, on all 3 switches. So let's go, that was switch A. Let's go to switch B and C, do the same thing, right? Global config mode, we said name, spanning tree, MST config. We said instance 1, VLAN 1, 10, 20. and revision is 1, and the name is group 1, just like that. Has the spanning tree priority for the VLANs on the switch changed? Let's check. Let's do a show span. Let's see here. We have, no, that is still, MST0 is 32768. We have 32768 for MST1 as well, right here. So it don't look like it. Still listening. Let's check switch A and see what happened there. Let's see what happened to his. Get out of this. Get out of that. Do a show span. Let's just do show span, right? MST1, the configuration, the priority is still 32768. So no, it did not change the priorities. Verify your MST configuration. How do we do that? We just do show span MST configuration. Show span MST configuration. And that gives us information about our MST configuration. We have the name. And remember what the analogy I like to use was country, state, and then city, right? So name or region, and then instance is the state, and then the VLANs are the little cities, right? So name group 1, instance 1, and then the little cities for the VLANs 1 through 1, 10, and 20, right? That's how I like to explain how MST is configured, right? And then configure switch B as the root bridge. Oh no, here's one thing they wanted to do here. I missed this part. View a summary state of the ports on the switches and verify that MST is running for MST 1, 10, and 20. The ports, we did show span summary, didn't we? Is that how we do it? Show span sum. We got 2 instances there, even though we only configured 1, right? Remember, there's a built-in one that gets created for the rest of the VLANs. That's called the internal spanning tree. It's MST0, which is also known as the internal spanning tree, or IST, right? So that's why there's 2 instances there. We created MST1, but there's this one that gets, that gets built in as soon as we turn on MST. What else we want to know here? Configure. Let's see here. Yeah, configure switch B as the primary root bridge for MST1. So right now, who is the root bridge? Let's see. Who the root bridge? Show span. Let's just do show span. Looks like this guy is the root bridge for MST1. What about MST0? He is also the root bridge for MST0. Right there, it says it right there. You see it? MST0, bloop. He is a root bridge. So he's a root bridge for MST0 and 1. Switch A. They want us to make switch B the root bridge for MST 1. Right? So let's go to switch B. We go to global config mode. And we said spanning tree MST 1. And we gotta say primary. So just like yesterday's stream, how we configure a root bridge. And then we say root primary. That makes him the primary root bridge for MST1. Right? And then they said configure switch C as a secondary root bridge. We only got 2 more tasks here. Configure switch C as a secondary root bridge for MST1. So he's primary root bridge. They want us to make switch C as the secondary root bridge. Switch C. We'll go to switch C. And we say spanning tree MST1 root secondary. So now he's the secondary root bridge. We can verify that with what? Show span. Right? Let's do a show span real quick. Show span. And we'll see the root bridge for MST1 is this guy. I am the root bridge for MST1. Right there. Final task. On switch B and C, display the priority for MST1. Well, we're already here. MST1, the priority 24576 for MST1. And then the secondary, which is the backup, this guy, what is his MST priority? For priority for MST1. Show span MST1 to drill down to just that MST instance. It is 4106. Interesting. That is interesting. I thought he would have been lower for MST1, right? MST1, he is the root bridge, but his priority is a little higher. That is really interesting. That's rather interesting. I wonder how that happened or what happened there. That is weird. He has a lower root bridge. I mean, he has a lower priority. However, he's the root bridge. Maybe they did that because, I don't even know. MST1, that's weird. That is weird. I don't know. We'll see. Let's, once you've completed this lab, be sure to check your work by using the grading function. You can do so by clicking the grade lab icon. So that's the one beauty about this application as well. When you're done with it, not only do they have the solutions at the end right here to let you know whatever the hell you fucked up or whatever you need to brush up on, and then you could also click the grade button and it tells you what we got wrong, right? So let's go ahead and pray to the network gods and hope we didn't get anything wrong, right? Lab, grade lab. Let's see what we're missing here. Maybe that's what's missing there. So see, I've got switch. See, I got these two red X's here that let us know we're missing something or we maybe did something wrong. So let's see. You missed one or more of the commands. So we click OK. Switch B. It looks like we forgot to disable BPDU on FA01. I thought they told us to re-enable it. I don't remember that step. I don't remember that step. Let's go back and check. Let's go back and check. What else did we miss on switch C? Oh, I didn't even touch switch C's MST stuff. So that's what we got to do. So let's go to switch B. Where's switch B? Switch B is, let's see, where is he at? Where is he at? That guy right there. And we said interface FA01, was it? I believe it was FA01. I can't remember. Was that FA01 or 04? Yeah, let me know. I think it was FA01. Let's do switch B. So yeah, we're pretty much done here. Let's do a show run real quick because I can't remember which one it was. It was the trunk port 01. They want that to be they want BPU guard enabled on here. And I thought I did that. Didn't I do that? Let's see. FA01. I remember they said right here. Oh, right there. Switch B's interface FA04. Enable port fast and BPDU guard. FA04 BPDU guard enable port fast. But they said on FA01 to do that as well. Is that what you said? I guess so. Enable, yeah, BPDU guard right there. So they want that turned up. I thought they told us to take it off, but whatever. Let's just do that just for the sake of the grades, man. The hell. Go to global config mode. And then interface FA01. Spanning tree. BPDU guard. BPDU guard. Enable. That turns on BPDU guard. And then we totally forgot the MST on the switch C, right? Didn't we? What was the configuration on that? We didn't do that? Show span MST config. No, we didn't do any configuration on switch C. So we need to do that. Go to global config mode. Global config mode. Spanning tree. MST. What was it? It was instance. Well, it was name. Jesus. Spanning tree. MST configuration. Name was group 1. And it was revision 1. And it was instance 1. Which was VLANs 1, 10, and 20. And then they wanted to make him the backup root bridge, which we thought we did, but we just didn't, we didn't even put that in spanning tree instance there. So that really screwed it up. Spanning tree MST1 root secondary is what we need to do. So spanning tree, that is probably why the, priorities was all jacked up too. So let's get out of this. You need to go to global config mode to set the root bridge. So spanning tree MST1 root. He is the secondary root bridge, right? Secondary. And I think that's pretty much it. Now let's do a show span MST1. And there it is. Now my priority is fixed. That's why it was all jacked up. I didn't even put MST on this switch right here. So that's pretty much it, man. Let's grade it up real quick. I'm pretty sure there's something I was missing. Let's see. Switch B, I was missing something. What am I missing on switch B? Oh, disable. You have to actually click disable. That's what happened. I negated the command by putting just removing the feature altogether. What you got to do is disable. So that's what I did wrong. That's what I did wrong. So I didn't understand this question. This is what I didn't see wrong on FA01. What was that question? Where was it? Let me see. Right here. That is what I didn't read correctly. On switch B's FA01 interface, explicitly disable BPDU guard. What I did was I said, oh, we'll just do no spanning tree BPDU guard enable. No, that just takes off the feature altogether. We don't want that. They wanted us to, like I said, explicitly say turn off BPDU guard, right? Because we could have it turned on globally on the switch, and that's what happened there. So we go back to that switch, and you see, and that is why we're receiving BPDUs right there, and it shut down the port again. So that is what happened there. So now it's probably in the disabled state, right? Show interface status, and we'll see it is in a NERV disabled state. That is why they wanted us to effectively disable BPDU guard there. He said, sorry, I missed a few streams, but are we sticking with Boston NetSim for now or going back to Paul Browning's CCNP book later? I'm mixing it up, man. I just been liking Boson NetSim. Like I said, they gifted me this free application. I'm gonna go back to the 101 Labs book, probably, if not tomorrow, then definitely Monday. What we're gonna do is, we typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. The next lab we're gonna do from Paul Browning's book, from the CCNP book right here, is gonna be MLS, Ether channels, and security. So if we don't do that one, we gonna do that tomorrow? I guess we can do that tomorrow if y'all really want to. If y'all really want to. Because, yeah, I know y'all probably tired of Spanning Tree and MST. We'll move on to Lab 4 tomorrow. And then hopefully I'll knock out the rest of this stuff on my own. I'm not going to stream every little thing I do, right? But I like mess with y'all, man. I like fucking with y'all. So we need to re-enable this port. Shut. And then Spanning Tree BPDU guard disable. That's what we need to do. Now no shut it. And that's what they wanted right there. So now we grade our lab, and now we've completed it successfully. Took a little bit because I didn't fully understand this question right here. I was like, well, just do no Spanning Tree disable. No, they said explicitly turn off BPDU guard is what they said here. They explicitly disable BPDU guard. And I thought just by negating the command that will disable it, but it really doesn't, because it'll still send BPDUs and stuff like that. So y'all roll my lights, man. If y'all like what y'all see tomorrow, I guess I think Kevin's tired of MST and Boson NetSim, so we'll get back to our 101 Lab CCNP book. And we'll try to do some port channels, Ether channels, and stuff like that. If you want a copy of this spreadsheet right here, this is what I'm semi-following right here. This is the stuff that we're studying. I've watched some of these CBT Nuggets videos and stuff like that. We did this lab last week. I think we did that lab last week. We did this one yesterday. We did the other one. We did Spanning Tree and MST lab today. The MST optimization, I think I'm going to do on that one. Maybe on my own tomorrow or tonight. Maybe, who knows. This lab I'll probably do on my own. Or I may do those tomorrow. But the next 101 Labs book, if we don't do that one tomorrow, definitely on Monday. Because I don't think I'm going to do it on Thursday. I don't know. We'll see. But what else I want to say? If you want to get a copy of this book, this spreadsheet here, make sure you join the Discord server. Let me give you an invite to it if you're not already, if you're not joined already. Rolling with my likes, man. Hit me with my likes, man. Please hit me with my likes, man. Make sure y'all subscribe to this channel. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. For now, comment, like, subscribe to the network.